Hi children, this is your Suvarna teacher. In this video, exclusively we are going to discuss about sp3 hybridization with examples methane, ammonia and water. Let me explain the formation of methane molecule based on hybridization concept. When bonds are formed, energy is released and the system becomes more stable. If carbon forms 4 bonds rather than 2, still more energy is released and so the resulting molecule becomes even more stable. As we know that the electronic configuration of carbon is 6 and the energy difference between the 2s and 2p orbitals is very small. When carbon atom is ready to form bonds to get a small amount of energy from bond energies and get excited to promote an electron from the 2s to the empty 2pz. That means in ground state the electronic configuration of carbon is 1s2, 2s2 and 2p2. But whereas in the excited state, the carbon atom will be shifted from 2s orbital to 2pz orbital. So, to promote, it get excited to promote an electron from the 2s to the empty 2pz to give 4 unpaired electrons. That means there are 4 half-filled orbitals, that is 2s, 2px, 2py and 2pz. We have got 4 unpaired electrons ready for bonding, but these electrons are in 2 different kinds of orbitals and their energies are different. We are not going to get 4 identically bonds unless these unpaired electrons are in 4 identical orbitals. How to explain the 4 orbitals of carbon containing unpaired electrons as energetically equal? We can explain it by the phenomena called hybridization. The concept of hybridization, as we know that the concept of hybridization was introduced by Linus Pauling. The redistribution of the orbitals of almost equal energy in individual atoms to give equal number of new orbitals with identical properties like energy and shape is called hybridization. The newly formed orbitals are called as hybrid orbitals. In the excited carbon atom, it's one s orbital, that means 2s orbital, and 3 p orbitals, those are 2px, 2py and 2pz. The 4 orbitals will intermix and reshuffle into 4 identical orbitals known as 1s and 3p combined they form sp3 hybridization, and these orbitals are known as sp3 orbitals. Thus, the carbon atom undergoes sp3 hybridization. The 4 electrons enter into the new 4 identical hybrid orbitals known as sp3 hybrid orbitals, one each as per Hund's rule, because they are made from the 1s orbital and 3p orbitals. They are called sp3 orbitals. The hybridization enables the carbon to have 4 identical sp3 hybrid orbitals and these have 1 electron each. Since carbon has 4 unpaired electrons, it is capable of forming bonds with 4 other atoms, maybe carbon or atoms of some other monovalent element. Children, monovalent means the elements which are having one as valency. When carbon reacts with hydrogen, 4 hydrogen atoms allow their s orbitals containing 1 electron each to overlap the 4 sp3 orbitals of carbon atom, which are oriented at an angle of 109 degrees 28 minutes. 4 orbitals of an atom in the outer shell orient along the 4 corners of a tetrahedron to have a minimum repulsion between their electrons. The nucleus of the atom is at the center of the tetrahedron. So, in methane molecule, carbon is the center. This leads to form 4 sp3 and s sigma bonds between carbon atom and 4 hydrogen atoms. All these bonds are of equal energy and the bond angle is 109 degrees 28 minutes and the shape of the molecule is tetrahedron and the hybridization which is present in methane molecule is sp3 hybridization. Now children, let me explain the formation of ammonia molecule based on the hybridization. Formation of ammonia molecule. One nitrogen atom and three hydrogen atoms are present in one ammonia molecule. All the three nitrogen and hydrogen bonds are of same strength and the bond angle is 107 degrees 48 minutes. So, let me see how the formation of ammonia takes place. Nitrogen has the electronic configuration 1s2, 2s2, 2px1, 2py1 and 2pz1. If three hydrogen atoms overlap their 1s orbital on the three p orbitals of nitrogen atom, they give identical ps sigma bonds, but then the hydrogen and nitrogen hydrogen bond angle should be equal to 90 degrees. But in practical, the bond angle of ammonia is 107 degrees 48 minutes. To explain the discrepancy in the bond angle, nitrogen atom is said to undergo sp3 hybridization. In this process, 2s and 2px, 2py and 2pz orbitals of nitrogen intermix and redistribute into 4 identical sp3 orbitals. Just like in methane, here also 2s and 2px, 2py and 2pz orbitals will undergo the sp3 hybridization. One of the 4 sp3 hybrid orbitals get a pair of electrons and the other 3 sp3 orbitals get 1 electron each because total electrons are 5. So, total hybrid orbitals are 4. So, according to the Hund's rule, each orbital should be filled by each 1 after then only pairing should be started. So, in the 4 sp3 hybrid orbitals, one sp3 hybrid orbital is filled with 2 electrons and the rest of the 3 hybrid orbitals are filled with 1 electron each. Now hydrogen atoms overlap their 1s orbitals containing unpaired electrons. The sp3 orbitals of nitrogen atom containing unpaired electrons to give 3 sigma s and sp3 bonds and the bond angle should be 109 degrees 28 minutes for sp3 hybridization as there is a lone pair in the one of the sp3 orbital is not participating the covalent bond with hydrogen. There is a greater lone pair bond pair repulsion which decreases the bond angle of ammonia from 109 degrees 28 minutes to 107 degrees 48 minutes. So the slight difference of the bond angle between ammonia and methane because of lone pair is present. Lone pair means which is not participating in the covalent bond present in ammonia, and this lone pair occupies more space around the central atom. So there is a decrease in bond angle in the case of ammonia, and the shape of the ammonia is trigonal planar. Next, pyramid. Next we will see the shape of the water molecule. It is found that in water molecule the bond angle is 104 degrees 31 minutes. The electronic configuration of the central atom oxygen is 1s2, 2s2, 2px2, 2py1, 2pz1 and for the electronic configuration for hydrogen is 1s1. Therefore, there should be 2 sigma sp bonds due to the overlap of s orbitals of 2 hydrogen atoms, the p orbitals of oxygen atom which contain unpaired electrons, then the bond angle in water should be 90 degrees, but the bond angle observed as 104 degrees 31 minutes. To explain this, sp3 hybridization is suggested for the valence orbitals of oxygen atom. One s orbital of, that means 2s, and 3 p orbitals, those are 2px, 2py, 2pz, intermix and redistribute into 4 identical sp3 orbitals, as there are 6 electrons and 2 sp3 orbitals get pairs and 2 sp3 orbitals get 1 electron each. So the valence electrons are 2, 2, 4 and 6. So the valence electrons are equally distributed among the 4 sp3 hybrid orbitals. So 2 of the sp3 hybrid orbitals will be placed as 2 electrons, and the rest of the 2 sp3 hybrid orbitals are having 1 electron each. Now the 2 sp3 orbitals of oxygen atom overlap the s orbitals of 2 hydrogen atoms to give sp3s sigma bonds due to the lone pair repulsion and lone pair bond pair repulsion. So the bond angle decreases from 109 degrees 28 expected for sp3 tetrahedral hybridization to 104 degrees 31 minutes. So here also the same reason we can say that the presence of the 2 lone pairs which are occupies more space around the central atom oxygen, so there is a slight difference in the bond angle of water. So now children, let us know the differences between sp, sp2 and sp3 hybridization. In sp, it is the hybridization takes place between one s atomic orbital and one p atomic orbital. In case of sp2, it is the mixing of one s atomic orbital with 2 p atomic orbital. In case of sp3, it is the mixing of one s orbital and with 3 p atomic orbitals. And in sp, the s characteristic percentage is 50%. In case of sp2, the s characteristic percentage is 33.33. In sp3, the s characteristic percentage is 25%. Whereas in sp, the p characteristic percentage is 50, and in sp2, the p characteristic percentage is 66.66, and in sp3, p characteristic percentage is 75%. And the angle between the orbitals in sp is 180 degrees. The angle between the orbitals in sp2 is 120. The angle between the orbitals in sp3 is 109 degrees 28 minutes. And the geometry of the sp molecule is orbital arrangement is linear, and in case of sp2, the geometry of the orbital arrangement is trigonal planar, and in case of sp3, the geometry of the orbital arrangement is tetrahedral. So children, that's all for this session. You're also going to learn hybridization concept once again in carbon compounds lesson also. Thank you children.